All right, so for my 6 bell students, and then for that last example, here's your walkthrough. And I will try and go quickly because you can pause this. All right, so we talked about the relationship between wavelength and frequency, so they always multiply to equal the speed of light. We can also relate the frequency of light to energy. So this was done by Max Planck, and he proposes a relationship between energy and frequency. And it's this equation here. So in the equation, E stands for energy. This is your Greek letter nu, which stands for frequency, same as the other equation. And then we have a new letter, and this stands for Planck's constant. And it's a constant, so it's always the same number. It's on the back of your periodic table. H is 6.626 times 10 to the negative 34th joules times seconds. And its units are just there to help cancel out other units. Your energy unit has to be joules, like we did back in the first unit when we did heat. And just like before, frequency is seconds to the negative first, or what's easier to type is hertz. All right. But those are the units. Again, it's very specific to the equation. You have to have it in the right unit. Okay. It is a direct relationship this time, so as one goes up, so does the other, and that should make sense. All right, waves that are coming at you with a low frequency, not going to cause as much damage and be as energetic as lots of waves coming at you. All right, even as I draw that, or you draw it on your paper, it should feel more energetic to do the high frequency waves. So this one says, determine the energy, and like everything else we do, write the question, looking for energy of light having a frequency of 2.4 times 10 to the 13th hertz. So again, frequency is the Greek letter nu. Label it in your problem. Here is your equation. E equals h times nu. You don't have to memorize. It's available on the periodic table. We don't know E, so we'll leave it as E. H is 6.626 times 10 to the negative 34th joules times seconds. And then frequency is 2.4 times 10 to the 13th hertz. And so hertz is a second to the negative first. So a second and a second to the negative first cancel out, which is why your unit on the constant is joules times seconds. That leaves us with just joules as our unit, and we will multiply these two numbers. Use your E button on your calculator. You get two significant figures, so E is, I have 1.59, which would round to 1.6, and then please remember to look for scientific notation, times 10 to the negative 20th joules. And these will always be pretty small numbers, because you are just finding one tiny fraction of the energy. It's the fact that when lots of the waves are hitting you that you can have damage or have issues. That's why UV light is bad for you. That's why x-rays are bad for you. They have high energy associated with them. Last example, same idea. We're going to calculate the energy. So question mark, energy of blue light with a wavelength of 485 nanometers. So this is where you have to be careful. This is wavelength. This is not frequency. This is your upside down backwards Y. This is your lambda. You have to pay attention to what each of the things, each of the numbers represent. So if we're trying to find energy, energy is H times frequency. So we know H, but we don't know frequency. So we have to find frequency. So in this case, you have to use both of your equations. We can take our lambda and we can plug it in to the first equation that we learned, and you can solve for frequency. Once you find frequency, we can take that and plug it in to find energy. Okay. We always know the speed of light, 2.998 times 10 to the 8th meters per second. The rule for wavelength is it has to be meters. So I'll do it up top. We'll take our 485 nanometers. And we'll do nanometers to meters. So 1 nanometer is 1 times 10 to the negative 9th meters. And that turns into 4.85 times 10 to the negative 7th meters. So again, absolutely 100% has to be in meters to use that equation. We'll plug that in for our lambda, and we'll solve for the frequency. Yep. So those will cancel. We'll divide, we'll solve. When we divide here, 2.998 e to the 8th divided by 4.85 e to the negative 7. And I get 6.18 times 10 to the 14th. I'm going to double check my count. Yep. Now we can take that number and plug it in for to solve for energy. H is always 6.626 times 10 to the negative 34th joules times seconds. We'll plug in our frequency, which I didn't get myself in the room, so we're going backwards. So technically your hertz and your little seconds will cancel out and leave you with just joules. We will multiply these two numbers. My calculator gives me 4.10, it's 4.095, so it would round up, times 10 to the negative 19th joules.